Alright, so this video will be on the metric system and scientific notation. So hopefully at some point you have seen and used the metric system and also gone over scientific notation. So hopefully this is a review for everyone. If not, it's okay. We're going to go over it. This is also the first video I'm assigning as a homework assignment. So make sure that you have your note packet out just like you normally would. And also, some of the podcasts, you really need to have a periodic table out, a calculator. But for this one, you need to make sure you have a pen and pencil and your note packet. Okay, so for the metric system is also called the SI system, or System International. And it's really the system that most of the world uses it, apparently, except for our country. We're a little bit behind. But people use the metric system because it's easier to use. There are base units and then prefixes. So an example of a metric unit would be a centimeter, a millimeter, a kilogram, a milliliter. And like I said, there's a base unit and a prefix. So your prefix is right here, centi. And then our base unit is the m, or the meter. So right here, our base unit is, again, the meter. And then right here, this is our prefix, and then that's milli. So right here, in this case, our base unit is the gram, and then our prefix is the kilo. And then here, our base unit is the liter, and then our prefix here is milli again. Okay, so the base unit will always come second. The prefix will come first. So the prefixes are going to be based off of powers of 10, and that's going to basically tell you how many times you need to multiply or divide by 10. All right, so some base units that we are going to be using in this class are the meter. So one of them is the meter, and that's represented with an M. And basically, if you look at a yardstick, it's a little bit more than a yard. So when we measure length, we're going to be talking in meters. When we're looking at mass, we're going to be talking about grams. So a gram is really about the mass of a raisin. So if you take a raisin and you feel what that feels like, that's about a gram. And a gram is represented with a little g. And then volume is going to be the liter, and that's about a half of a 2-bottle liter. Okay, so remember, volume is really how much space something takes up. Mass is almost the same thing as weight, but weight is slightly different. Okay, so here are some of our basic prefixes. We have kilo, hecta, deca, deci, centi, and milli. These are our most basic ones, and I remember the order of the prefixes with a saying. The saying is, King Henry died drinking chocolate milk. So, King Henry died, base unit, drinking chocolate milk. So the K, or king, is kilo. H, Henry, is hecta. The first D is deca. And then the second D will be deci. The C is centi. And then M is going to be milli. And then right here, this is what each of the prefixes means. So kilo is equal to 1,000, hecta is equal to 100, deca is 10, deci is 1/10, centi is 1 out of 100, milli is 1 out of 1,000. So basically, the prefixes to the left of the base unit represent larger units. So everything to the left of here is larger than whatever your base unit is. So the gram, the meter, the liter. So a kilometer is larger than a meter. A hectometer is larger than a meter. A decameter is larger than a meter. Okay? The prefixes to the right represent smaller units. So deci, centi, milli would be smaller than the base unit. So a centimeter would be smaller than a meter. A millimeter would be smaller than a meter. Now, what I do to remember how much is what is I basically look at where the base unit is in respect to whatever the prefix is. What I mean by this is I look at K. K is kilo, okay? And it is, if I count, it's 1, 2, 3 places away from the base unit. Okay, so a kilometer and a meter would be 3 units away. So really, if I had a kilometer, 1 kilometer is equal to 1,000 meters. And I know that because the kilo is 3 places away from the base unit. 1, 2, 3. So it has 3 zeros. And a kilometer is bigger, so it's 1 kilometer is equal to this many meters. Okay, so now let's look at hecta. So hecta is 1, 2 jumps or units away from the base. So a hectometer is equal to 100 meters. So 1 hectometer is equal to 100 meters here. And I know that because it's 2 places away from the base. So same thing with deca. I'm going to count. It's 1 place away. So 1 decameter. Or you could use, it's actually like DK. 1 decameter is equal to 10 meters. Okay, remember the 1 will go with the larger unit. All right, so now let's look at deci. Remember, everything to the right of the base is going to be smaller. So really, the base unit should be larger. So if I'm looking at meters, 1 meter is equal to how many decimeters? And deci is going to be, is just going to be a lowercase d. It's just d. Deca is usually represented with a dk. All right, so now if you count between the deci and the base, there is 1 place, so there's 1 0. 1 meter is equal to 10 decimeters. Let's look at centi. Count. 1, 2. It's got 2 places, so it has 2 zeros in that. So 100 centimeters is equal to 1 meter. All right, now let's look at the milli. I'm going to count. 1, 2, 3. It's 3 places, so again, 1 meter is equal to 1,000 millimeters. So this is what I do to remember how much is equal to whatever unit. I count the places it is, and then that's how many zeros goes with the smaller unit. All right, so a few more prefixes we're going to be using are micro and then also nano. So a micro, meter or gram or whatever it is, 1 micrometer in this case is equal to 0.0000001 meters. I don't like having to remember how many zeros that is, so you can also say that 1 meter is equal to a million micrometers. I can also say this, and we're going to talk more about this when we get to some conversions. This would actually be the same thing here. All right, so one more unit, nano. We are going to be using this in a little bit. 1 nanometer is equal to 0.000000001 meters, or something the better way to say it would be 1 meter is equal to a billion nanometers. And some more zeros, okay? Or I could say 1 meter is equal to 10 to the 9th nanometers. Okay, so these are two that you kind of just have to know. You can't really use a saying to figure out what it is. You just kind of have to memorize it. Okay. All right, so let's talk about scientific notation. Okay, so scientific notation is basically used to convert big numbers into small, usable numbers. It's used to help keep calculations precise. It's much, much easier to use scientific notation than to have to put all the zeros out because you're more likely to make a mistake. Okay, so this is what we do with scientific notation. We take a big number and then make it into something that's a little bit more usable. So what you do when you have scientific notation or you're trying to convert to scientific notation is you move the decimal until there's one digit to its left. So it's going to be the decimal and then there's something to the left. So right here, the decimal, that's not really there. We're going to move it until there's only one number in front of it. So 1, 2, 3, 4. Okay, so that gives me the first part. It's 6.5. Okay, that's my number. Now I need the exponent. Well, I moved it 4 times. That's going to be my exponent. Okay? Okay, so now if you're trying to decide if your exponent should be positive or negative, basically if your number is larger than 1, it's positive. So if it's a big number, it's positive. If it's smaller than 1, it's a negative exponent. So right here, ignore that dot, that shouldn't be there. It's going to be a positive exponent because this number is large, so it should have a positive exponent. So it's 6.5 times 10 to the 4th. And this is only important for honors, but you will only include significant figures in scientific notation. Okay, so let's do a few of these. Okay, so we're going to convert to scientific notation for the first two. So again, let's take our imaginary decimal and move it. 1, 2, 3, 4, 5, 6. So it's 2.4. I moved it until there's only one number in front of the decimal. And I moved it 6 times. And since this is a large number, the exponent is positive. So it should be 2.4 times 10 to the 6. All right, so now let's move this one. And this one we're actually moving the opposite direction. So 1, 2, 3. So I moved it until there was only one number in front of the decimal, which would be here. So it's 2.56 times 10, and I moved it 3 times. But since this number is small, it's smaller than 1, it is a negative exponent. All right, so now if I want to convert it back into expanded form, what I'm going to do is I'm going to take my number. Here's 7 times 10 to the negative 5th. Okay, so here's my decimal right here, my imaginary decimal. I'm going to move it 5 times. And since it's a negative exponent, I'm going to move it so that the number is less than 1, or I'm going to move it to the left. Okay, so 1, 2, 3, 4, 5. And then any of these spaces I just fill in with zeros. Okay, so it's 0.00007. Okay, kilometers. All right, so now I'm going to expand this one out. So again, I'm going to take my number, and then I'm going to move the decimal 4 times. And since it's a positive exponent, I'm going to make the number larger and move the decimal to the right. So 1, 2, 3, 4. So it's 62,000. And then notice it's not that there's 4 zeros there. It's that I moved the decimal 4 times. Okay, so we're going to be doing a lot of stuff with scientific notation. I do have a practice handout. If you want some practice, I have a link on my website to get to some extra quizzes if you'd like to get some extra help. All right, I'll see you guys in class.